This session is on how to read the standard normal distribution table. This table is located in your course material, table number 3, the first table, in appendix number 1. During the first week of the course, we looked at continuous random variables and discrete random variables. We defined a random variable as a numerical outcome of an experiment. For example, the weight of a student. Now, a continuous random variable, we spoke in week 1 that these variables are measured, obtained by measuring. These variables can be whole numbers or fractions. And we also said that these variables the values would lie in a range. The continuous probability density function. Now, let me just back up a bit. The continuous distributions, normal distribution is a continuous probability distribution, and so we will be looking on continuous random variables. Now, when we looked at discrete probability distributions, these values were exact values and could be represented on a probability distribution table. Now, the continuous distributions, these are represented on a graph. So here you will see I have a graph, and we have the values of x on the horizontal axis, the values of y, which would represent the frequency on the y-axis, and the area under the curve is where we would find our probabilities, right? So our continuous probability density function, that graph, shows all the possible values of x and the frequencies associated with these values. Now note that f of x is not your probability. In order to find the probability, you'll have to find the area under the graph. And point 2 here, speaking about properties, indicates to us that the total area under the graph is equal to 1. Now, to find the area under the graph, you will have to do a mathematical concept referred to as integration. Now, we don't need to know to do integration for this course because all the areas were calculated for us and displayed on the table that we'll be looking at today. Right? However, we need to know that the total area under the graph is equal to 1. We'll be using that property during the course of our discussion today. Now, some other properties of our function. Notice I have here f of x is greater than or equal to 0, meaning it falls in that positive quadrant. And the values of x, as I indicated, are on my x-axis. Now we're looking at the normal distribution curve, right? So we're looking at the special continuous distribution, which is called the normal distribution. Now this is a continuous distribution. The shape of it is bell-shaped. Most of the data is in the middle. It is symmetrical with the mean, mode, and median at the same point. Now, as I mentioned earlier, to find the probabilities, you'll have to find the area under the curve. Now, how do we do that? Right, if we were integrating, if we wanted to find the probability that x lies between c and d, we'll have to integrate the function between those points. But as I said before, the probabilities are given to us in a table. Now, the table that we have is referred to as a standard normal distribution table. And the random variable for this table is denoted by z. All right, so we reserve z to denote the random variable. So z is a standard normal variable, and z is normally distributed. The mean is 0, and the variance is 1. The standard deviation is also 1. If you recall, the standard deviation is the square root of the variance. So this is something we have to bear in mind, that the table that we have is a standard normal distribution table. So the mean is 0 and the standard deviation is 1. Now, if you look at the table, you will realize that there's a little graph at the top right hand, and it shows you the area greater than a positive value for z. right? This is very important. You may pick up other tables and it's showing you the different areas. So whenever you pick up a standard normal distribution table, you have to look to see what area is shown on that table, right? Now this table that we have in the appendix is what you'll be getting in the exam. So in other words, the table you'll be getting in the exam shows you the area under the curve for values greater than a positive x. So if we want to find the probability that z is greater than 1.08, in other words, we want to find the area under the curve for a value of z greater than 1.08. Now to read the tables, on the extreme left, you have the whole number and one decimal place. So you'll see 1.0, and then you'll go across to get the second decimal place. So 1.08 probability would be 0.1401. So the probability that z is greater than 1.08 is 0.0401. Okay, so if we want to find the probability that z is greater than 2.34, again, the whole number and the first decimal place is on the extreme left, 2.3, and we will go across to the column with the 7 to get that second decimal place, and the value will be 0.00889. That would be the probability that z is greater than 2.37. What if we are required to find the probability that z is less than 2.37? Now the table will show us the area for z greater than 2.37, right? But we are required to find this shaded region less than 2.37. We know, however, that the total area under the curve is equal to 1. So if this unshaded area that we can read from the table is 0.00889, then this shaded region, in order to find that value, we'll do 1 minus 0.00889. So the probability that z is less than 2.37 will be equal to 1 minus 0.00889, which gives us 0.9911. Okay, so you'll see it's not all the time that you'll be asked to find the probability that z is greater than a positive value. We can also have the probability where you have to find it less than a positive value. And so you will realize that we have to do some manipulation. What if we need to find the probability that z is less than negative 2.37? Now on my left, I have a little diagram showing you the area we're interested in. And I find that drawing the diagrams help you to see exactly where the area is that you're interested in, and then how you're going to manipulate in order to find that area. So I'm interested in finding this area on the left of negative 2.37. Now you may realize the tables don't have negative numbers. It has only positive numbers. So if I just redraw, and you may realize now on the left here, I have the area I'm interested in. On the right, you realize that the area that is greater than 2.37 is the same as the area less than 2.37 because the graph is symmetrical. Okay, so therefore the probability that z is less than negative 2.37 is the same or equal to the probability that z is greater than 2.37. And so we can go to the tables. 2.3, we'll go across to 7, and we'll realize that the answer would be 0.00889. Next example, we want to find the value of probability that z is greater than negative 2.37. Again, I'll draw a little diagram. Negative 2.37 will be someplace on that left area, remember in the middle, where it peaks correspond to 0. So negative 2.37 will be somewhere on the left. Greater than negative 2.37 would be that shaded area. Again, I don't have negative values on my table, so I'm going to redraw. using positive 2.37. And I'll realize that this area on the left is equal to the same area that the area that I'm interested in, because the curve is symmetrical. So the probability that Z is greater than negative 2.37 is equal to the probability that Z is less than 2.37. Now it says less than. Earlier we looked on an example where we know how to handle situations where we have to find less than a positive Z value. What we will do is 1 minus the probability that Z is greater than 2.37. Okay? So our answer would be 1 minus 0.00889, which is 0.99111. Here we want to find the value that Z lies between 0.44 and 1.53. So I've drawn a little diagram. Z lies between positive 0.44 and positive 1.53. So it's this shaded area that we're trying to find. Okay, now what we will do, remember our table shows us all the values greater than a positive value. So we'll find the area greater than 0.44, which will be everything to the right of 0.44. But then we'll take out this little piece, this little unshaded area that we don't want, which is the values of Z that are greater than 1.53. So the probability that Z lies between 0.44 and 1.53 is the probability that Z is greater than 0.44 minus the probability that Z is greater than 1.53. Okay, so since these are saying greater than and a positive value, we go straight to the tables and find those corresponding areas. Now, what if we need to find the value that Z lies between negative 0.44 and positive 1.53? Again, as usual, I'll draw a little graph to see exactly the area that I'm interested in finding. Okay, to find this area, I will find the probability that Z is greater than negative 0.44. That is everything to the right of 0.44. And then I'm going to take out this little area that is greater than 1.53. So I've made a note. The probability that Z lies between negative 0.44 and 1.3 is the probability that Z is greater than negative 0.44 minus the probability that Z is greater than 1.53. Now, greater than negative 1.44, we looked on a slide before where we looked on how to find if it's greater than a negative number, and if you recall, it would be 1 minus the probability that Z is greater than 0.44. Then we will continue minus the probability that Z is greater than 1.53. Okay, so it's equal to 1 minus, and these are the corresponding probabilities. We will compute to get the answer to be 0.607. Okay, so you get the idea. You won't always get the probability that is greater than a positive number. You can get combinations of probabilities, and you will have to be able to manipulate the tables. Let's find the probability that Z lies between negative 1.53 and negative 0.44. If I draw the areas here on the left, you'll see where I drew the area that we're interested in. We don't have negative values, so I will draw it on the right here using positive 0.44 and positive 1.53. And you can see that the area that I'm interested in is the same area as the probability that Z lies between 0.44 and 1.53. And that was an example that we looked on before. We know that we'll find the probability that Z is greater than 0.44, that is everything to the right of 0.44, minus the area greater than 1.53. All right, now here are some examples, or well, some questions for you to try. Make a note of those and you can try them. You can consult your e-tutor to ensure that you have the correct answer on these questions. This is the end of the presentation. Kindly listen to it again. If the first time you didn't understand, listen to it again, and if needs be, get back to me with your questions. Bye.